Good morning once again and welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, we are looking at example 10 of differentiations, Pure Mathematics 4 and page 59. And it's still talking about rate of change. We're still talking about rate of change. And we have understood that rate of change, we have differential equations. And what we need to understand is that the head of a snowman of radius r centimeters loses volume by evaporation at a rate proportional to its surface area. We must get that well. The head of a snowman of radius r centimeters loses volume by evaporation at a rate proportional to its surface area. Assuming that the head is spherical, that the volume of a sphere is, we're talking about volume of the sphere is 4 over 3 pi r cubed centimeter cubed, and that the surface area is given by 4 pi r squared. Write down a differential equations for the rate of change of radius of the snowman's head. Write down the differential equations for the rate of change of radius for the snowman's head. So we are supposed to talk about dr dt, rate of change. First of all, we know the first sentence tells you that the dv dt is minus ka, because what does it say? That the head of a small snowball of radius loses volume. So dv dt is minus k, loses volume by evaporation at a rate proportional to its surface area. That is clear. Where volume where v is the volume, t is the time in seconds, of course k is a positive constant, and a is the surface area of the snowman's head. So with v being equals to 4 over 3 pi r cubed, we must now talk about dv dr, which is 4 pi r squared. It goes without saying. And having said that, it is simply going to talk of dvdr is just that, 4 pi r squared. And the question asks for a differential equations in terms of r. So you need to use the expressions for volume in terms of r, which is here. The chain rule is supposed to be used because this is a related rate of change. So as much as I'm talking about dv dt in this particular sense, the rate of change of volume dv dt is supposed to be dv dr times d dr dt, which is, of course, dr dt is here. This one is going to be dv dr is known to be 4 pi r squared times dr dt. But of course, we know that dv dt is something else. We know dv dt is minus ka. But since dv dt is minus ka, meaning that we must talk of 4 pi r squared times dr dt, which is dv dt, times dr dt, which is equals to minus k times 4 pi r squared. I want to explain that part. We are told that, let me just show everything. The volume is 4 over 3 pi r cubed. Area is 4 pi r squared. And the question is dr dt. We need to talk about dv dt. The dv dt is the rate of change of volume with time is proportional to, or it loses volume at the rate proportional to the area. So minus Ka, that one is because of the word loss. The word loss in the first statement. So dv dr, which we may be able to get dv dr is here. We differentiate that statement. We can even get dA dr. I don't know whether we need it. dA dr is 8 pi r. 8 pi r, that is dA dr. But if you may want to talk about dv dt, which is already given here, is equals to dv dr multiplied by dr dt, which we are finding. Eventually, we should have talked about dr dt is going to be equals to dr dv times dv dt, which is exactly what is supposed to be. But dr dv is 1 over, which is 1 over 4 pi r squared times dv dt, which is equals to minus k a, which is 4 pi r squared. That is what we should have gotten there. This is now dr dt. So dr dt is supposed to be minus k 4 pi r squared all over 4 pi r squared, and you cancel the whole of that and you realize that dr dt is easily minus k, and that is the rate of change of radius with respect to time. I have switched from using this to just bring in this chain rule, which is very clear to everybody. But even this one, we can continue with this one and finish. We can still continue with this one and finish, making dr dt the subject of the formula. In this particular one, dr dt is equals to minus k 4 pi r squared over 4 pi r squared, and you cancel the 2.5 minus k. Either way, you should be able to get there. But this one seems a little bit straightforward because dv dt is known here, minus ka. You can detect that from the question. A is this. We just have to have dA dr just in case we need it. And because the question is on dr dt according to the chain rule is dr dv, which can be expressed here times dv dt, so that dv and dv cancel out and we are left with dr dt. Incidentally, dr dv happens to be the reciprocal of this, because this one is showing us dv dr. It happens to be the reciprocal of this, which is 1 over 4 pi r squared times dv dt, which is expressed in the question, and we have seen that minus ka, simply because there's a word loss. So minus k, and the area is this. So it goes without saying that if you multiply out everything, dr dt is going to be minus k 4 pi r squared over 4 pi r squared, and this cancels out, and the dr dt is simply minus k. So the rate of change of radius with time is negative k. So please note that you have been able to bring all the information on board and use them. Again, welcome or visit my YouTube channel and do everything possible to understand that question. All right.